Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through everything you need to know for the upcoming test. So let's get started with the blue, which is statistics. Then we'll go through the black, which is measurement, and the red, which is percentages. So we'll start with the mean, median, mode, and range. These are things you calculate of a set of scores or a set of data. So the mean, median, and mode are measures of central tendency. This means the reason we calculate them is to give us an idea of the center of our data. What is a typical score? The range, on the other hand, is a measure of spread. It measures whether the data is close together or not. So we've got a set of 6 scores here, and we're going to go through and calculate each of these. So we'll start with the mode. So the mode is the most common score, the score that occurs the most. So in our set of 6 numbers, 44 and 72 both occur the most. So when you have what we have here, which is 2 modes, we say the data is bimodal, as opposed to if there's just one mode, we say it's unimodal. So the mode's the easiest to calculate. Now the median is a little tricky. So the median is the middle point of the data, but what makes it tricky is you calculate the median slightly differently depending on whether they're an odd or an even number of scores. Now whenever you calculate the median, regardless of the number of scores, what you need to do is you need to have the data in order from smallest to largest. So all I've done to get from here to here is write the data from smallest to largest. Now the median is the middle point of the data. So here we have 6 scores. We have an even number of scores. When there's an even number of scores, there will be 2 middle scores. So what we do is we can cross out each data starting at the smallest and then the largest. Then we cross out the second smallest and second largest. And finally, we'll get to the middle data points. So as I said, when you have an even number of scores, there are 2 middle scores. So when that happens, when there are 2 middle scores, to find the point halfway between those, you add the 2 scores and divide by 2. So you can use your calculator for this if you like. The median here is 68.5. So the median is the point in the data such that there are the same number of scores above it or below it. So here you can see 3 scores above 68.5, 3 scores below 68.5. That's why we say it's the middle of the data. So when there's an even number of scores like here, then you have 2 middle scores, you add them up and divide by 2. If you have an odd number of scores, then the median is one of the data points. So the median is the point in the data such that there are the same number of scores above it or below it. So let's now look at the mean. So the mean is probably the one that takes the most work to calculate, but it's the easiest to remember what it is. To find the mean, just add up all the scores and divide by how many there are. So if I go 89 plus 44 plus 72 and so on and add them all up, I get 386. So there are 6 scores. I divide the sum of the scores by 6. So I get 64.33 and it goes on forever. So just note the mean need not be one of the scores. So lastly, the range. So again, the range is different. All of these calculations were done to give me an idea of the typical score or the center of the score. The range measures how spread out the data is. So to find the range is really simple. You just take the largest score and you subtract the smallest score. So in this case, it's 89 minus 44, which is 45. So you can't compare the range to the mean, median, or mode because they measure different things. So let's now look at some frequency tables. So this is what a frequency table looks like. You have a list of scores and their frequency, how many times they occurred. So what these numbers here are saying is that in this data, we had, the score 1 occurred once, and 6 occurred twice, and 7 occurred 3 times, and so on. But we don't want to write out all of these scores because it takes too long. So let's say each of these scores here represents someone scoring our weekly Canvas quiz. So you can see that no one scored 2, 3, 4, or 5, so I don't need to include them in the table. Now I'm going to introduce you to the word outliers. So outliers are numbers that are much smaller or larger than the other scores. So in this data here, 1 is an outlier because it is a lot smaller than the rest of the scores. If we're talking about our Canvas quiz, this student did much worse than all the rest of the students. So outliers can be a lot larger or a lot smaller than the rest of the data, and you can have more than one outlier. So what we're going to do is show how outliers affect the mean and median. So how would we use this table here to calculate the mean and the median? We'll start with the median. So the number of scores in this data set is 1 plus 2 plus 3 plus 2 plus 4 plus 6. So let's add up all of these numbers, we get 18. So down here, this says the sum of frequencies is 18, or in other words, there were 18 scores. So how would we find the median if there were 18 scores? Well, a trick you can use is n plus 1 on 2, where n is the number of scores. This formula doesn't tell you the median, it tells you which score is the middle score. So if there are 18 scores, I go 18 plus 1 over 2 is 9.5. What that means is the median is halfway between the 9th score and the 10th score. So let's find the 9th lowest score. So 1 plus 2 is 3, 6, 8. So there are 8 scores that are less than or equal to 8. So the 9th, 10th, 11th, and 12th scores are all equal to 9. So the median of this data is 9. So how are we going to use this table to find the mean? Well, as I said before, what this means is the score 1 occurred once, 6 occurred twice, and so on. So we need to, in order to find the mean, add up all of the scores. We could go 1 plus 6 plus 6 plus 7 plus 7 plus 7, but that would take a long time. Instead, we construct the fx column. The numbers that go here are these two multiplied together. So I go 1 times 1, 6 times 2, 7 times 3, 8 times 2, 9 times 4, and 10 times 6. So if I add up all of these numbers, I get 146. So that's what this means here, the sum of the fx column. So 146 is the sum of all the scores. 18 is the number of scores. So the mean is 146, the sum of all the scores, divided by 18, how many there are. So it's 8.11 and so on. So let's now look at what the mean and median would be if I don't include the outlier. So if I didn't include the outlier and I get rid of that, there are now only going to be 17 scores. So using this formula here, number of scores plus 1, 17 plus 1 divided by 2 is 9. The median would be the 9th score. So we have 7 scores less than or equal to 8. So the 8th, 9th, 10th, 11th scores are all 9. The median is still 9 if I get rid of the outlier. If I look at the mean, I don't need to recalculate everything. The scores added to 146. If I take away the score of 1, they now add to 145. And there are only 17 scores. So to 2 decimal places, this is now 8.53. So what happened was, when I got rid of the outlier, this student who did poorly, the mean went up from 81% to 85%. It went up 4%, which is quite a lot. But you can see the median didn't change at all. And that shows you that the mean is more affected by outliers. When I add the outlier in, it would reduce the mean by 4%, whereas the median wouldn't change. So the reason for this is when you calculate the mean, you use all of the scores in your calculations. When you calculate the median, you're only interested in the middle scores, not the really large or really small scores. So for that reason, because the mean is more affected by outliers than the median, if your data has outliers, then I apologize, then this should say the median is a better measure of center. It's the median that measures the data better when you have outliers in your data. So an example of this would be house prices. See, most house prices in Canberra, they're probably like 400,000 to 600,000. But then you have these outliers. You have these really expensive houses that cost, maybe $2 million. So that means if you look at house prices, there are outliers in the data. There are houses that just cost way more than all the others. So that's why when you hear people report on house prices, they mention the median house price, but not the mean. The mean is not a reliable measure when there are outliers. All right, so I'm going to get rid of all these calculations. Please pause and copy down if you need. So we can also use information about the mean and the number of scores to find the value of one of their scores. So let's do this question here. So let's say after all of these 18 students took the test, another student took this Canvas test, and after they took it, the mean decreased to 8. What was their score? So we know that the sum before they took the test, the sum of all the scores is 146. We calculated that. So we can figure out what the scores would add up to, what the sum of the scores would be after he takes the test. So after he takes the test, there will be 19 students who've taken the test. If the mean is 8, then the sum of the scores will be 19 times 8, which is 152. So because the mean is the sum of scores divided by the number of scores, if you want to find the sum of the scores, what they add up to, all you need to do is times the number of scores by the mean. So, number of scores times mean gives you the sum of the scores. So, the sum of the scores before he took the test was 146, afterwards was 152. So, his score must simply be 152 minus 146, which is a score of 6. All right, let's now go on to types of data in collection. So there are two types of data that I can collect: numerical or quantitative data. The other one is categorical or qualitative data. So to determine which type of data you are collecting, you need to ask yourself, would people respond with a number? So let's say I want to collect data on eye color of students at Marist. So if I ask a student, what is your eye color, they're not going to respond with a number, they're going to respond with a category, like blue eyes or brown eyes. So eye color is categorical data, because if I ask someone their eye color, they wouldn't give me a number. So if I want to know the most common eye color amongst students at Marist, there's two ways I can do this. I can engage in a census, which is where I ask everyone in the population, or a sample. That's where I ask just some people in the population. So here, the population that I'm talking about is every student at Marist. So if I want to know the eye color, the most common eye color of students at Marist, the best way would be to ask every single student at Marist. That is called a census. That's where I ask everyone that I'm interested in. But that might take a while because there are lots of students at Marist. So instead of asking everyone, I might just ask some of the students at Marist. So for example, I might just ask students in Darlinghurst. This would be a sample. I'm just asking a subset of the students at Marist. So when you're getting data from a sample, not from everyone, you need to ask yourself, is your sample representative of the population? In other words, will you get similar results from asking your sample as you would if you asked the whole population? So if you would get similar results, then your sample's unbiased. If no, your sample is biased. So if I asked the students at Darlinghurst what their eye color was, I'd probably get similar results as if I asked everyone at Marist. So Darlinghurst students are an example of unbiased students. If you're wanting an unbiased sample, it's always good to do it randomly. If you ask people randomly their eye color, it will be unbiased. So an example of a biased data set would be, let's say I just asked people their eye color if they had light skin. That would be a biased sample because people with light skin are more likely to have light-colored eyes. It's very rare someone with, say, dark skin has blue eyes. So if I just asked students with light skin, that would not give me similar results as if I asked everyone. So that would be an example of a biased sample. All right, that's all for statistics. Let's move on to measurement. So we start with perimeter. So perimeter is the length around the outside of a shape. So here, for this shape here, we don't know each of the sides, but remember when we're finding perimeter of a shape, we don't necessarily need to know all of its sides. So I don't know what this side is and what this side is, but I know that together they would add up to 6 meters. Similarly, I don't know what this side or this side is, but together they would add up to 5 meters. So the perimeter of this shape is 6 plus 6 plus 5 plus 5. So that would be 22 meters. That is the distance around the outside of this shape. So let's look at this circle here. So even though this heading says perimeter, we don't call the outside of a circle the perimeter, we call it the circumference. It has a different word because technically a circle has no sides. So the formula for the circumference of a circle is diameter times pi, or 2 times pi times radius. So pi is just a number, 3.14159, a button on your calculator. The radius is the distance from the circumference to the center of the circle. The diameter is the distance from one side of the circle to the other through the middle. So the diameter is always double the radius. That's why you can use either of these formula. That's why there's a 2 here, because 2 times the radius gives you the diameter. So the circumference or distance around the outside of this circle is just the diameter times pi. So if you put that on your calculator to 2 decimal places, you should get 37.70, and it's centimeters because the radius and diameter were in centimeters. So how would we find the perimeter of this shape here? This time I call it a perimeter because it does have some sides. It has straight edges. So to find the perimeter of this part of the circle, which I call an arc, this here, what I'm going to do is I'm going to find the perimeter as if it were a whole circle, and I'm going to divide by 4 because this is 1/4 of a circle or a quadrant. I know it's a quarter circle because this is 90 degrees. 90 is a quarter of 360. So to find this length here, the arc length, it's 2 times pi times radius. 10 here is the radius, distance from circumference to center of circle. But I'm going to divide this by 4 because it's only a quarter of a circle. So if I put just this part on my calculator, I get about 15.71. That is not my answer though. That is only this length from here to here, only the curved length. To find the perimeter, I also need to add this side and this side. They'll both be 10 because they're radius of the circle. So the perimeter of this whole shape is going to be the curved side plus the 2 straight edges. So it's going to be 35.71, and my answer's in millimeters because the measurements were in millimeters. So make sure you write your units whenever you're finding area, perimeter, or anything like that. All right, that's all for perimeter. Let's move on to area. So you need to be able to find the area of each of these 6 shapes here. So we'll start with a circle. So the formula for area of a circle is pi r squared. So here, if the diameter is 12, the radius would be 6. So the area of this shape here is going to be pi times radius, which is now 6 squared. So putting that on calculator to 1 decimal place is about 113.1. And when we're doing area, it's in square units, so centimeters squared. So let's look at this shape, a parallelogram. A parallelogram is a 4-sided shape with 2 pairs of parallel sides. The formula for area of parallelogram is base times perpendicular height. So this 10 here has nothing to do with the area. the area of this shape is just 8 base times perpendicular height, which is 9. 72 meters squared. Now, I don't know why, but people always seem to want to divide by 2 for the area of a parallelogram. You do not divide by 2 for the area of a parallelogram. You do divide by 2 for the area of a triangle. The area of a triangle is base times perpendicular height divide 2. The reason we divide 2 for a triangle, it's half a rectangle. So the area of this triangle is just 15 times 6 base times perpendicular height divide by 2, and that's 45, and the answer's in meters squared. So the hardest shape to find the area for everyone seems to be a trapezium. So the area of a trapezium is perpendicular height divided by 2, and then you times it by the sum of the 2 parallel sides. So for this trapezium here, the area would be perpendicular height divided by 2, so 6 divided by 2, times the sum of the 2 parallel sides. A trapezium only has 2 parallel sides, unlike a parallelogram. So this would just be 39 times 3, which gives us 117 meters squared. So make sure you practice trapeziums because they always mess people up. So let's look at this shape here. So this is a kite. It's actually a special type of kite known as a rhombus. A rhombus is like a slanted square. It's a shape it's a 4-sided shape with all sides equal. So the way you find the area of a kite is you times the 2 diagonals, so one diagonal x, one diagonal y, you times the 2 diagonals together and divide by 2. The diagonals of a quadrilateral are the lines joining non-adjacent vertices. So this line is a diagonal even though it's like horizontal. This line is a diagonal even though it's vertical. So the area of this shape is the first diagonal times the second diagonal and divide by 2. So putting that on the calculator, you get 90 centimeters squared. That's the area of this kite. So the area of a rectangle is very easy. You've done this a million times. So 10 times 7, length times width, and we get 70 meters squared. So just remember the difference between a rectangle and a parallelogram. A rectangle has 4 right angles, whereas a parallelogram doesn't necessarily have any right angles. So just make sure you understand trapezium, kite or rhombus, and triangle. They are the 3 sides where we divide by 2 to find the area. All right, let's now look at a more problem-solving kind of question for area. So the perimeter of a rectangle, 30 centimeters, width is 7. What is the area? So I'll just start by drawing this rectangle here. So if the perimeter is 30 centimeters, it means it's 30 centimeters around the outside of the shape. So what that actually means is the length and the width will add up to half of 30, which is 15. So this side here I'll call the width, and this side here I'll call the length. They add up to 15. The reason they don't add to 30 is because we need 15 plus another 15 to get to 30. So here, the width, we're told, is 7. So then the length would just be 15 minus 7, which is 8 centimeters. So now I know the length is 8 and the width is 7. The area is really easy. It's just 8 times 7, length times width, which gives 56 centimeters squared. All right, let's now look at finding the area of composite shapes. So composite shapes are where you have 2 shapes stuck together, like here, or one shape cut out of another, like we do here. So in the first one, we're just going to find the area of the 2 shapes and add them together. Here, we're just going to find the area of the big shape minus the area of the small shape. So looking at this shape here, this is a trapezium plus a semicircle. So I'm going to call the trapezium shape 1 and the semicircle shape 2. So for the area of shape 1, the trapezium, remember the formula is perpendicular height divided by 2, and you times that by the sum of the 2 parallel sides. So we get 136 meters squared. So the area of the semicircle. So the area of a circle is pi times radius squared. So here the diameter is 12, so the radius would be 6. But we need to divide it by 2 because it's not a full circle, it's only half a circle. So to 2 decimal places, we get 56.55. So the total area of this shape here is just going to be this first shape plus that shape. Just add those two together and you get 192.55 meters squared. So let's say that this was someone's lawn, and let's say it costs $30 per square meter to lay down a lawn here. So the cost of laying down this lawn would just be $30 per square meter times this number of square meters. It's just 30 times 192.55. And so you get about $5,776.50. So that's the kind of working out you would do if you get, like it costs this much per square meter to do something. You first find the area of the shape and then you times by the cost per square meter. So let's look at the second shape here. So this is different because it's not two shapes added together, it's one shape cut out of another. So what we have here is a rhombus, which is a type of kite, and it has a rectangle cut out of it. So here we're going to find the area of the kite. So I'm just going to put AK for that. So it's going to be the two diagonals multiplied together and then divided by 2. So the area of the big shape, the big kite, is 100 centimeters squared. So the area of the rectangle is just going to be length times width, which is 24 centimeters squared. Now this time we're not adding the two together. It's not two shapes stuck together. It's the rectangle cut out of the big shape. So the total area is big shape minus small shape, which leaves us with 76 centimeters squared. All right, let's now have a look at converting units. So here we're converting things like millimeters to centimeters or centimeters squared to millimeters squared. So there is a chart for how you convert units of length here. You're probably already familiar with that. Now what messes people up is when you're converting square units, what you need to do is square the conversion factor. So these blue numbers are what I mean by the conversion factor. So for example, there are 10 millimeters in a centimeter, but there are 10 squared or 100 millimeters squared in a centimeter squared. Similarly, there's 10 millimeters in a centimeter, but there's 10 cubed or 1,000 millimeters cubed in a centimeter cubed. So normally, if I'm converting from millimeters to centimeters, follow the arrow, I divide by 10. If I convert from millimeters squared to centimeters squared, I divide by 100, and millimeters cubed to centimeters cubed, I divide by 1,000. So you can use these charts. If you can just memorize this one, then just know that you have to square everything for square units and cube everything for cube units, then you'll be fine. The rule here is if you want to go from a smaller unit to a larger unit, you divide, because there are fewer of the larger unit. On the other hand, if you want to go from a larger unit to a smaller unit, you times. So a larger unit like meters to centimeters, we times because there are more centimeters than meters. So let's look at these conversions here. So I want to go from 1.3 kilometers to meters. So chart, from kilometers to meters, I times by 1,000. I just go 1.3 times 1,000 on my calculator, I get 1,300. So in this one, I want to go from millimeters to meters. So millimeters to meters. What I need to do is divide by 10 to get to centimeters, and then divide by 100 to get to meters. So there are actually 1,000 millimeters in a meter. So what I'm going to do here is I'm going to go 4,750 divided by 10. So that's 475 centimeters, and then divide by 100. So 4,750 millimeters is 4.75 meters. So now let's look at converting square units. I want to go from meters squared to centimeters squared. Meters squared to centimeters squared, I times by 100 squared, which is 10,000. So people get mixed up here. They think, okay, cool, there's 100 centimeters in a meter. So I will just take 3.4 and times by 100. No, you don't do that. What you do is you take 3.4 times it by 100 squared. So you actually get 34,000. Now you take 3.4 and times by 100 squared. You don't square the 3.4. You only square the conversion factor 100 squared. So I got my answer here by going 3.4 times 100 squared. So similarly, to go from millimeters cubed to centimeters cubed, I follow this chart. I divide by 10 cubed. So I take 43,000 and divide by 10 cubed, and I'm left with 43. So one thing that's not on these charts is hectares. So people always get mixed up with this. 1 hectare is 10,000 meters squared, or 1/100th of a kilometer squared. So if I want to convert 5,000 hectares to kilometers squared, I need to times by 0.01, or in other words, divide by 100, because there are 100 hectares in a kilometre squared. So 5,000 hectares is 50 square kilometres. So how many metres squared would be 5,000 hectares? 1 hectare is 10,000 metres squared. So if I want to go from hectares to metres squared, I'm going to times by 10,000. So this will be a very big number. It actually ends up being 50 million. So make sure you practice these conversions, because these bring people undone all the time. So let's now move on to volume and capacity. So area is the amount of space that can fit inside a two-dimensional shape. Volume is the amount that can fit inside a three-dimensional shape. These two shapes here, triangular prism and a cylinder, they are three-dimensional. They have length, width, and height. They are the three dimensions. Both of these shapes turn out to be prisms. They have a consistent cross-section. So the cross-section is a shape that's like repeated at the front and the back. So here the cross section's a triangle. These two triangles in green are the same triangle and the same size. A cylinder is, for all intents and purposes, a prism. Its cross section is a circle. So the circle's repeated at the bottom and also the top. So that's what we mean by consistent cross section. So if you have a prism, the formula is volume equals AH, area of the base times the height. So, the volume of this rectangular prism, I find the area of the base, so the area of a triangle, base times perpendicular height divided by 2. So that gives me 48 centimeters squared. That's the area of the triangular base. So the volume is just the area of the base times the height of the prism. So it's 960 centimeters cubed. So that is the volume. So the capacity of a shape, the only difference between the capacity and the volume is the units you use. So volume, we use cubic units that you saw on the previous slide. Millimeters cubed, centimeters cubed, whatever. Capacity uses milliliters, liters, or kiloliters. We can easily convert between units of volume and units of capacity. A centimeter cubed is a mil. So if this prism here is 960 centimeters cubed, it will hold, its capacity will be 960 milliliters of liquid. So 960 milliliters is 0.96 liters. To get from milliliters to liters, I just divide by 1,000, because there are 1,000 milliliters in a liter. Once again, if you're going from a small unit to a larger unit, milliliters to liters, we divide. So this prism here would hold 960 mils of water, or 0.96 liters. So let's find the volume of this prism here. So the volume is just the area of the base. So the base is a circle. Another word for base is cross-section. So the area of this circle is pi times radius squared. So if the diameter is 4, the radius will be 2, half of the diameter. So the area of this circle is pi times radius squared, and then you just times that by the height of the prism. So putting that in my calculator to one decimal place, I get 75.4 meters cubed. So that is the volume. What about the capacity? Well, 1 meter cubed is actually 1,000 liters or 1 kiloliter. That's what kiloliter means, just 1,000 liters. So this, if I want to find out how many liters it would hold, I times it by 1,000. So it would hold approximately 75,400 liters of liquid. So think about it. If we made a cylinder like this, it's very big. It's almost like as big as a house. It would be absolutely massive. So that's why it would hold so many liters of water. All right, let's now look at a problem-solving question involving volume. So a cylindrical can is to hold 600 mils of liquid, radius 2 centimeters. What would be its height? So here we know the volume. We want to find a dimension, one of the lengths. So what we do is we get our equation, volume equals AH, and we're going to substitute in everything we know. So for this cylinder, the area of the base would be pi times 2 squared. Pi times radius squared. So when I times that by whatever the height is, I will get 600 mils, which is 600 centimeters cubed. So to find out what the height is, I need to undo multiplying by pi and 2 squared. So what I'm going to do is I'm just going to take my volume and divide by the area of the base. So if you take the volume and divide by the area of the base, that gives you the height of the prism. So all I need to do is put this on my calculator now. And so if I put that on my calculator, I get about 48.14 centimeters. That would be the height of this prism, so that when you multiply the height by the area of the base, you get 600 centimeters cubed or 600 mils. All right, that's all for measurement. Let's move on to percentages. So we're going to start by finding one quantity as a percent of another. So these type of questions are where you don't know the percent already. So to illustrate the usefulness of this, we're going to go through this example. So let's say I scored 68 out of 80 in my maths test, 50 out of 60 in my science test. On which test did I perform better? So this is why percentages are useful. It's hard to know which is better, 68 out of 80 or 50 out of 60. It's really hard to compare these two fractions because they have different denominators. See, that's what percentages are. They are just fractions. So what I'm going to do to see whether I perform better on maths or science, I'm going to change these fractions so that they have a denominator of 100. That will make it really easy to compare. So what I need to do is find out which number goes here and which number goes here. So we're going to use the rules here. If you have a fraction or a decimal and you want to go to a percent, you times by 100. So that's where we get this formula from. To convert 68 out of 80 into a percent, I just took my first quantity, the marks I scored, over second quantity, the total number of marks, and times by 100. So to find out what number goes here, I go 68 over 80 times 100. The answer I get is 85, which is 85%. To convert 50 over 60 into a percent, I take 50 over 60 times by 100, and I get 83.33%. That's rounded to 2 decimal places. So 85% means I scored 85 hundredths of the marks available. And for this test, it means I scored about 83 out of every 100 marks. So you can see clearly I did better on the maths test. It's easier to compare these two now. 85 over 100 is clearly larger than 83 over 100. So I got a greater proportion of marks on the maths test. That's why percentages are useful, and this is how you convert one quantity as a percent of another. First quantity over second quantity times 100, and you have your answer as a percent. So let's look at how we can use this in financial mathematics. So the way we can use one quantity as a percent of another in financial mathematics involves profit and also discounts. So profit is when you make additional money from selling something. You see, if you want to make a living and be able to buy food, if it costs you, I don't know, $10 to make a table, you can't sell it for $10 because then you won't make any money. You won't have enough money to buy food. So what you're going to do, if it costs you $10 to make a table, you're going to sell it for more than $10. And that extra money you get is a profit. If it happens that you sell something for less than it cost you, that's called a loss. So the profit, more formally, is the selling price minus the cost price. The cost price is what it costs you to make it or buy it, and the selling price is how much you sell it to somebody else. So what we're going to do is we're going to calculate the percentage profit. It turns out this is just calculating one quantity as a percent of another, just like we did on the previous slide. So let's say it cost me $20 to make a shirt and I sell it for $48. What's my percentage profit? Well, the profit I make is the selling price, how much I sell it for, minus how much it costs me to make. The profit I made here is $28. So if I want to find my profit as a percentage, it's understood that I mean as a percentage of the cost price. So what I'm going to do is I'm going to take my profit, the first quantity, divide it by the cost price, the second quantity, and then I'm going to times by 100, just like on the previous slide. First quantity divide second quantity times 100. So in this case, profit over cost price times 100 is 140%. So I made a profit of 140%. Now this makes sense because if I made a profit of 100%, that means I would be selling something for double what it cost me. This one I sold for more than double what it cost me to make. That's why my profit is more than 100%. All right, let's now look at finding the percentage discount. So this was the original price reduced to this price. What is the percentage discount? So the amount of the discount is just the original price minus the new selling price. So originally it sold for $3.20. I reduced it to $2.30. So that means the price has gone down by $89.60. That's how much the customer is saving. That's the amount it's been discounted. So $89.60 is the amount of the discount. So to find the percentage discount, I'm going to write the discount. I'm going to divide it by the original amount and times by 100. First quantity over second quantity times by 100. So in this case, $89.60 was the amount of the discount. The original price was $3.20, and I times that by 100. My answer I get is 8%. So putting that on my calculator, I get 28. So the answer is 28%. That means this price has been discounted by 28% to get this price. All right, let's now look at finding a percentage of a quantity. So when we found one quantity as a percent of another, we didn't know what the percent was, and we had to find it. Here, we know the percent, and we're calculating a quantity. So here, we're saying, what is 60% of 85? I know the percent, and I want to find a quantity. So what I do is I convert the percent to a fraction or a decimal. If you want to convert a percent to a fraction or decimal, you do the opposite of what we've been doing to this point. You divide by 100. So 60% of 85, I just go 60 over 100 times 85, because of means times. Or you can go 0.6 times 85. Both of them will give you the same answer of 51. 60% of 85 is 51. In other words, if I did 51 over 85 times 100, I'd get 60. 51 is 60% of 85. So what you do to find percent of a quantity, you convert the percent to either a fraction or decimal by dividing by 100. It doesn't matter whether you do fraction or decimal, and then you just times by the quantity. So let's look at a worded problem here. School of 1200, 54% have blue eyes. How many students is this? So I'm finding 54% of 1200. So I convert the percent to a fraction or a decimal, doesn't matter. So to go from 54% to here, I divide by 100. 54 divided 100 is 0.54. So after converting the percent to fraction or decimal, you multiply it by the quantity. And putting that in my calculator, I get 648. So that means 648 of the 1200 students here have blue eyes. So let's now look at how we can use percentage of a quantity. We can actually use this for percentage increase and decrease. So to increase by R%, you times by 1 plus R over 100, and to decrease by R%, you times by 1 minus R over 100. So the only difference between these two, you plus when you're increasing and you minus when you're decreasing. What we're actually doing here is just finding a percent of a quantity. So let's illustrate this in this example here. So video game normally $125, discounted by 20%. What is its new price? So we are decreasing 125 by 20%. So we take our amount and we times by 1 minus 20 over 100. See, what we're essentially doing here is we're finding 80% of 125. 1 minus 20 over 100 is 0.8 or 80%. So the reason that we're doing this is because if you take 20% off the price of something, you're only paying 80% of the price. So 125 times 1 minus 20 over 100, putting it in your calculator and being careful as you do it, you get $100. So taking 20% of 125, we're left with $100. This is 80% of 125. That's what we did here. We found 80% of 125. So let's look at this question here. Cost pizza shop $4 to make a pizza. Place a 225% markup on the cost price. What's the selling price? So what we're essentially doing is taking $4, the cost price of the pizza, and increasing this time by 225%. So this time it's 1 plus 225 over 100. The reason it's plus because we are increasing. That's what markup means. You increase the price in order to make a profit. So we're increasing 4 by 225%, and all you need to do is put that on your calculator and you get $13. So that's what they will sell each pizza for. So what we've essentially done here is we have found 325% of 4. If you take 100% full amount and add 225%, you have 325% of it. So these formula here and these examples, we're just finding a percent of a quantity. Here we found 80% of it by decreasing by 20%, and here we found 325% of the quantity by increasing by 225%. All right, now we're going to use percentages to find the original amount. So here we're finding the original amount. What I mean by that is we've taken some number, we've done some percentage magic to it, and we have a final amount. Here we know the final amount, but not the amount we started with. So when you're trying to find the amount you started with, you divide instead of multiplying. So think back to the previous examples. One quantity is a percent of another. We timesed by 100. When we were finding a percent of a quantity, we timesed the quantity by the fraction or decimal. We times when we were increasing or decreasing by a percent. But when we're finding what amount we started with, we divide instead of multiplying. So this is the kind of question that we will get. So at a school, 45% of students are boys, 387 are boys. How many students attend the school? So you might be thinking, well, how is this the original amount? Well, what we're saying here is we took some number of students. This is the number of students at the school. And then we took 45% of it. So that's the same as timesing by 0.45. And we ended up with 387. This is the final amount after 45% of this number has been taken. So the way that we're going to figure this out is divide instead of multiplying. Instead of timesing 387 by 0.45, I'm going to divide 387 by 0.45. And putting that in our calculator, we get 860. There are 860 students who attend the school. If you take 45% of 860, you get 387. We divided because we're finding the original amount. So let's look at this question here, which is a bit harder. The price of a cologne decreased by 25%, now costs $123. What was the price before the discount? So what we're saying is we took the original amount, we decreased it by 25%, and we ended up with a final amount of 123. Here I know the final amount, and I want to find the original amount. So remember, subtracting 25%, taking away 25%, if I decrease something by 25%, I times by 1 minus 25 over 100. So I've taken my original amount, I've times by 1 minus 25 over 100 to get this. So I want to find the original amount. I'm going to divide instead of multiplying. So instead of timesing 123 by this, I'm going to divide 123 by this. I don't want to decrease 123 by 25%. I want to find what number I had originally so that when I decrease it, I get 123. So on my calculator, I'm going to put 123 divided by 1 minus 25 over 100. I get 164. That makes sense. The answer I get should be more than 123. See, if I take 164 and decrease by 25%, I get 123. That's why the original price was 164. All right, final thing we need to do in the video, let's look at rates. So a rate is just a comparison of two quantities of different types. That means two quantities that have different units. Rates are always something per something. Now, speed is a rate that you would be familiar with. Speed is distance per time. It's like meters per second or kilometers per hour. So let's look at this question here. I can run 100 meters in 15.625 seconds. What is my speed in meters per second and kilometers per hour? This is a rate, meters per second, something per something, and this is a rate, kilometers per hour. They compare different quantities because this is a unit of length, this is a unit of time. They're comparing distance and time, two different quantities. So to find my speed in meters per second, that's really easy. All I have to do is divide 100 meters by 15.625 seconds. So the answer I get there is 6.4. So that means I can run 6.4 meters per second. In other words, on average, each second, I can run about 6.4 meters. So now I want to know what's my speed in kilometers per hour. So think of this rate as saying I go 6.4 meters in 1 second. So in 1 hour, I would go how many meters? Well, I'd go 6.4 meters per second. So this is how far I would go in 1 minute. At this same rate, I'd go 384 meters every minute. So in 1 hour, I'd go 384 times 60, which is 23,040. I'd go 23,040 meters every hour. So we didn't want meters per hour, we wanted kilometers per hour. So we need to convert this into kilometers. Lucky we looked at converting units before. To go from meters to kilometers, you divide by 1,000. So this is actually 23.04 kilometers per hour. I'm saying if I can run 100 meters in 15.625 seconds, that means on average I run 6.4 meters every second. If I kept up that rate for a whole hour, I would go 23.04 kilometers, or 23,040 meters. All right, let's now look at the unitary method for rates. So let's look at this question here. Petrol costs $50.88 for 48 litres. How much will 76 litres cost? And how many litres can I buy for $100? So we're going to use the unitary method to do this. So to use the unitary method, you first find the value of 1 unit. So I want to know how much 76 litres will cost. The unitary method is I first find out how much 1 litre will cost. So 1 litre will cost the amount divided by 48. So that gives me $1.06. That means each litre will cost $1.06. 1 litre costs $1.06. So 76 litres, well, that will just cost 76 lots of $1.06. That's all I need to do. And so if I put that on my calculator, I get $80.56. That's how much I'll pay for 76 litres. So now I want to know how many litres can I buy for $100. So the unitary method is to first find the value of 1 unit. What I'm going to do with the unitary method is I'm going to find out how many litres I can buy for $1. So I do a similar calculation as I did before, I just switch them around. So this many dollars gets me 48 litres. So $1 will get me 48 over 50.88. So you might be a bit confused which number goes on top and which goes on the bottom. Well, here I want to write the rate as litres per dollar. So that's why dollars goes on the bottom because it's on the bottom of this fraction, and litres goes on top here. Just like up here, I wanted to find dollars per 1 litre. So I put dollars on top and litres on the bottom. So if I put 40 over 50.88 in my calculator, I do get a really long, weird number. So the answer I get is about 0.943396, and it goes on, has more decimal points. So what that means is, for $1, I can get 0.943396 litres. This is how many litres I get for $1. So if I want to know how many litres I can get for $100, all I need to do is times it by 100. I just take my answer from before, this is how many litres per dollar, and times that by 100. So I get 94.3396 to 4 decimal places. This is how many litres I can get for $100 at this price of $1.06 per litre. All right, sorry for such a long video. Best of luck studying in your test, but you're a superstar. You will ace it, and I'm proud of you. Thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.